All right, guys, we got a quick set of notes here. So this is gonna be the last thing that we learn about in our momentum unit here, and this is kind of an important thing. And so the title of this, let me zoom. The title of this is going to be force and momentum. And the essential question we want to ask, and for the essential question, I'm going to go ahead and okay, the essential question is how are force and momentum related? Okay, and this is going to be, I think you guys are going to see that this is going to be a really good applicable set of notes for us. So there's stuff this can do for us in the real world, which I think is kind of cool. Now, real quickly, I'm gonna use a disclaimer, and I'll use a different color here. Okay, I'm gonna write this in red. I'm gonna draw an equation. I'm gonna show you how this relationship works based on an equation. If you don't understand this fully, it's okay. This is not the most important thing for you to understand. But I know that there are some of you out there that math makes sense to you. I changed my mind. I'm going to write it in green. Math makes sense to you, and I want to write this equation just so you have it if you want it. So here's what I'm going to start with. Okay. So I know that force is equal to mass times acceleration. I also know that acceleration is equal to change in velocity over change in time. So what I can do is I can take this quantity here and I can plug it in for acceleration. So what I'm going to end up with is force equals mass times delta V over delta T. And when I rewrite that, it could look like this. F equals M times delta V divided by delta T. Now what I want to do is I'm going to go ahead and we can think of it like cross multiplying. So I can multiply there and I can multiply there. So I'm going to end up with F times delta T equals M times delta V. And now this is important because I can think of this in regular words now, okay? So force times time, and that's going to be the time over which the force happens. Okay? I'll explain that more in a minute. Equals mass times change in velocity. Now, here's the really cool thing is that mass times change in velocity, we have another way of saying that because mass times velocity, so let's remember this, that P or delta P equals mass after minus mass before. Excuse me. That's not right. Delta P equals mass times velocity after minus, there we go, mass times velocity before. So if we pulled an M out of there, I'd end up with M times VA minus VB, which looks an awful lot like that. So here's what we're really saying. Force times time equals change in momentum. Okay, so those of you that didn't follow that, it's totally okay. This is what we want to know. Force times time equals change in momentum. And when I say that, okay, force is the force of collision time is the time it takes for momentum to change. I'm going to explain that in a second. For momentum to change. And then delta P is just change in momentum. Okay, so we've all got this. Now let's think about an example, okay? So this has all been confusing so far. It will all make sense with my example, okay? And so here's our example, airbag. So we think about a car crash, okay? And so normally what happens, if there is no airbag, we have a steering wheel, okay? There's my steering wheel. And then I have somebody's head. Let's see if I can draw nice. Okay. So there's a head. Little eyes and a mouth. So normally what happens is when the car slams on the brakes, this person here, they're just driving along, and boom, their head bounces off the steering wheel. Well, that doesn't feel very good. So what an airbag does is it inflates. Okay? And now, when your head flies forward, it hits the airbag first. Now, your head is going to experience the same change in momentum, okay? So it still has to slow down just as much as it did when it hit the steering wheel. But what the airbag does is it increases the time it takes for your head to slow down. Now, the really cool thing here is that if I look back up at my equation, if I look at this equation right here, for the change in momentum to stay the same, if my time increases, okay, so this is important. If time increases, then force decreases. So for our face here, by increasing the amount of time that it takes for the head to hit the steering wheel, it's actually decreasing the amount of force that your head hit the steering wheel with, which means that you don't get hurt quite as bad. Okay, that's the set of notes. After you take this set of notes, you're going to see what we're going to do with this information.